Right, well, good afternoon, everybody. My name is Rob Berglund, and I'm with the Weather Company. The Weather Company is now part of IBM, so it was really great that we had an IBM person speak first, and I got to hear a little bit about that. But IBM acquired what is the Weather Company about a year ago. And that is, the Weather Company is kind of what you would think of as weather.com, Weather Underground, if you've heard of that, the Weather Channel kind of digital properties, all of that sort of a big umbrella as part of the largest weather company in the world. And IBM acquired us about a year ago for some very specific reasons of bringing together really deep core competence in weather with what IBM was doing, the cutting edge of what IBM is doing, partly of which has been talked about the past two presentations, analytics, predictive modeling, things like that. So I specifically want to talk just a little bit about what it is that we're doing that's different from a weather perspective for forecasting. We're doing something that I've been with the Weather Company for about 14 years. And this really is, in the past couple of years, we've really changed the way that we had to do stuff in order to get extremely hyper-local, which is where more and more of the business is happening, more and more of life-saving, things like that are happening. So I think most of us can agree that there's some changes going on in the world. And those changes are doing some things. I mean, they're getting more and more severe than they ever have been. Okay? Some people would argue, and this is part of everything you read in the news, right, that this is just cyclical. Some people would argue that, no, there's real change going on in the atmosphere caused by stuff that we do, right? That this is not a political set of slides or anything like that. I don't really have a stance that I can give you, and I don't want to. But I think we can all agree that there's some major changes that have to do with catastrophes caused by all kinds of variety of severe weather that we didn't used to see before. Certainly, we talked about the tropical, picture, things coming tropically, tornadoes, even things that you might not be used to, but severe icing events, things like that, for example. Okay, but there's an impact that's happening because of that, and of course they're very costly. They're not only costly monetarily, but they're costly on people as well. Okay? But the implication, the ones that we can see right here, what this really has to do is a picture of what things used to cost and kind of where it's escalated to here in this chart. On the right-hand side, this is just like a cost per day of different hazardous type storms in particular. All of that is increasing. Okay, so really then what I want to talk about is what is it that we're doing that is any different from a weather perspective versus what we used to do? And what is it going to mean to business? What is it going to mean to life and limb? Things like that. Okay. First and foremost, I think we're at the right conference because we're talking about connection. We're talking about IoT here. And our story, part of the game changer that we're doing, has a lot to do with new data sources via connection. Okay, so keep the IoT picture in your mind, that we didn't used to do. Many of those are non-traditional sources that a weather vendor would never do before. So I'll give you some examples of that here in just a second. So more and more data is coming in through our building. We ingest about 24 terabytes of data per day. On a busy day, like a bad weather day, globally speaking, could be 100 terabytes. It takes a revolutionary cloud-based platform to be able to handle that. Some of the new data sources that we're bringing in, back in 2012, we acquired a company called Weather Underground, and you guys would have heard of them. One of the great things that they brought to our business was that they had weather stations, and they had a lot of them. And even last year, we were growing that network of weather stations, contributing about 5,000 per month. We're up to about 250,000 personal weather stations. Some of those are business class. The only stations we used to have, really, the ones that you could rely on, were the airport locations. The problem with that, as you can imagine, is trying to predict a disaster here from something that's happening in Atlanta, right, is a big jump. That's a big interpolation, and that opens up room for all kinds of error. So, how much could we rely on these is a big question. And so we've done some advanced analytics in QC/QA to bring in a large majority of those through a network that helps us to do something with what's happening right now and what's about to happen. Okay, so both the right nows and the predictions, the forecasts. Okay, we didn't used to have those before. We used to have about 50 models. We have about 162 weather models coming in. It's a lot of data. Atmospheric data from airliners. We're huge in the airline business, commercial airline in particular. United, American, Delta. Most of those outsource their dispatch and en route functions for weather to our company. And as a result of that, you get a lot of data that comes back from airliners crisscrossing the atmosphere that just a weather balloon couldn't get. I'm actually kind of surprised that you guys are in this room because they launched a weather balloon outside, and I thought everybody would be out there watching that. Has it gone up yet? Okay. Hopefully it has a GPS on it. And you know, NOAA, who is responsible for launching most of the weather balloons in the atmosphere, for whatever reason, I think it said it had to do with budgetary, but most of those weather balloons, if not all, don't have like a tracking mechanism where you can see, you know, exactly the lat long that it's centered over. In other words, the thing gets blown around, you kind of tend to lose track of where exactly in the atmosphere it is. Anyways, this is a non-traditional source of weather ingest that we're doing now. Another one that's really bizarre that most people wouldn't think of is this one here on the far right. This has to do with mobile phones. Because of the Weather Channel app, some of you guys have that on your phones. The native app that's built into Apple, or even now Samsung, that was new news, is our data that I'm going to tell you guys about today. And there's about 200 million downloads of that. And of that, about 15 million, would say, recurring active users are saying, yes, it's okay for us to know where I'm at, so the location. And then, yes, it's okay for you to pull some data off the phone. Some data would be like barometric pressure, temperature. We throw temperature out because we can't trust it, you know, it's in your back pocket or in your car or whatever. But pressure survives all that. And it's a new source of data that didn't used to be there before. Soon enough, connected cars will be on the far right of this screen as well. Really non-traditional sources of new data. There's a lot of it. It needs a lot of love. It needs a lot of attention, a lot of QA, QC. But it's giving us a picture of where things are happening that didn't used to be there. As a result of that, we're squeezing that data down into a very tight grid, about 500-meter resolution. So our story has a lot to do now with new precision. We're always after this, accuracy. And what you won't hear from me today is that we've got the super duper never wrong forecast, because that doesn't exist. But it's better than it used to be. And after 14 years of being here, I can testify that that's a true statement. And then, of course, to be able to deliver 500-meter resolution all over the world takes a revolutionary platform to do that. That's part of being at IBM. There's a big, big contributor there. Okay. So we have about 100 times more, this is globally, 100 times more sensors than public sources that are available out there. So the big contributor, we kind of get, people tend to get their head wrapped around this a little too much because it's not the main source of data. But it is interesting. I mean, this is the weather station story right here. And this is just a look at some cities around the world. What you're seeing on the screen right there is the red dots. That's the publicly available sources of primary weather input. Usually, again, the airports, believe it or not. Sometimes some others. But you can see the problem, right? Everybody else lives here, or they live over here. They're not living, or they're not working, or operating, or saving lives, or producing energy at these other places. Or harvesting crops, all these business cases. They're all over these other places, but the red dots really is where most weather vendors, us included, where we used to be, could sense, and then for the most part, we would predict where we could sense. Okay? In order to predict, the best prediction needs the best source of what's happening right now, and that used to be these, the red dots. The blue dots are the personal weather stations that are part of this 250,000 number that we keep talking about. And you can see what that does, where the people live and work and operate, right? It's a massive difference. Okay? It's not the only one, but it's a great, great story because of what we do from there. So this is a blown up view of that. Now this is a great example because this is San Francisco. San Francisco offers a great weather case because they've got these little microclimates all over the place. You ever been out there? You know that if you're on the left side of this picture, right, it's cold. You get that marine layer that comes in, you probably put your jacket on and you might even get a little wet in the morning, right? But if you move out towards Oakland or you move a little bit more to the right, okay, it could be 90 degrees on that same day. It can be hot, right? And you better be in shorts and short sleeves. These are the airports. And so we used to sense at these airports and then make a prediction off of those airport locations because that was the best source of what's happening right now. Kicks off the whole weather model. And then if somebody wants to know what's happening here, you do a big interpolation to get there. Okay? I'm oversimplifying that, but that's kind of how it would work. This is what it looks like now today with kind of this new way of doing things. Okay? And this will impact our ability to detect, predict severe weather as well. But that same picture, that same geography where the airports used to be here and here, this is now this 500-meter grid, and you get a sense, that's temperatures Fahrenheit that you're seeing in those little color bubbles, right? The green is like in the 60s, the yellow's in the 70s, and you move out to the right, it's like in the 80s and even the 90s in the top right corner of this picture. That's a massive difference in that San Francisco Bay Area. There's a lot of places like this in the world, mixing of water with land, topography like terrain relief, a higher elevation and a lower elevation. Okay? And that does all kinds of things chaos-wise with the weather. So we used to forecast about 1 million points on the face of the Earth, and we do them about 5 times a day. It was a lot of data 5 years ago. We do 2.2 billion now for locations, and we do them every 15 minutes. Okay, so that is a massive difference, and that's part of this game-changing way that we're doing the weather differently. So part of the ecosystem that I thought might be relevant, to this crowd has to do with products built on that high precision, low latency, really granular weather data. And they have to do with things like ground transportation or oil and gas. Here's a dashboard that's radar-based, meaning a very now new, small, portable, 2-person carry radar put on something like an offshore platform in areas of the world where there was no weather. There was no real weather there, right? There was no help from the government to get them there, nothing like that. The ability to predict outages, right? This is outages due to severe weather. So instead, I'll talk about this in a second, but instead of sort of guessing at what kind of outages are going to happen based on the storm that somebody's looking at on their phone or their computer, this is now a predictive modeling based on machine learning that tells you exactly what mobilization level, how many tickets you would expect for outages, and then what to do about it. Certainly alerting, Steven talked about alerting a little while ago. We have a robust program for alerting, even something new for mobile locator. This is interesting for this audience because this has to do with a partnership with a company called Laser that the old 911 system, when you would call up, was built in in 96. The problem is that it had a latency in terms of trying to find out when you called in exactly where you were, and it usually was off by about a few city blocks, it could be. So they really couldn't pinpoint you if you called in and you needed help. There's a disaster happening. You're standing out here in the roof of the flooded building and you're saying this. If your communication breaks up, it was hard to locate. This is now something new that has no latency and can predict within about 20 meters where you are when you call in for 911. And then, of course, high-resolution data to support most of what we do. So this is that new system called 911 Mobile Locator. And it really is something that we're really super excited about because here again, we think it's a game changer in responding and to dealing with severe weather. Okay? 911 takes about 175 million calls a year. And again, they can't really precisely locate just off of the phone call where you're at. So that's a major, major problem that we try to engage on and we are solving. And so again, the precision and the non-latency, that it's not going to take a minute to locate, and the location shouldn't be off by more than about 20 meters is where we're at with this new product here. This one is more near and dear to my heart because I'm a guy that grew up in energy. So with the utilities, with trading natural gas and power, electricity, this has to do with predicting outages. So, for many utilities, the answer to what do we do to get power restored again has to do with Bob. Bob is down the hall. Bob's been here 30 years, right? And he's got a phone and he's got a computer and he's looking at the radar coming in, and we all walk down the hall to Bob and say, Bob, this looks pretty bad. What do you think? Well, Bob's been there 30 years and he kind of says, I think the answer is this. We rolled this many crews of this type and, to get the best power response back on. That's tough, number one, if Bob ever leaves. Number two, Bob is usually prone to error, even though he's been there 30 years, he's pretty good at guessing, the weather story. Even a trained meteorologist would have a hard time doing that outside of a machine learning environment. So this is now a machine learning, very digitized environment that looks at historical outage data from, say, a utility, for example, combines it with historical weather data, machine learning environment then looks at storms coming up and predicts the correct level of mobilization needed. It is pretty accurate. Right? It's about 80% accurate within the first 3 days, okay? And less than 1% on false alarms, which means, hey, roll this many crews, say several hundred people, and getting that wrong, which is very costly as well in terms of over mobilizing. Okay, so this is a fairly new thing. It came out of IBM research and development, and the weather company took it, decided to invest heavily into it, and now produce it mostly for the utilities, though it works for telecom as well, and a lot of other industries. This one has to do more with oil and gas and even a version for ground transportation. And this is that portable radar I talked about. This is not a picture, by the way, of the portable radar. That's not. That is. It's small enough that a two-person carry can put this out in an area where there hasn't been good radar coverage. A lot of media stations actually use that to enhance what they do at the 6 o'clock news. We use it for the obvious reason that there's a lot of areas in the world that aren't getting help from like government radar, for example. Okay, a lot of oil and gas examples for this. But the idea is a dashboard that takes in that real-time from radar, picking up hazardous weather of all types, and puts it on a mobile tablet and lets all the workers that are associated with that environment see really what's going on. And then we move the radar forward in time. In other words, we put it in a model and predict the next 12, 24 hours of what's going to happen based on an area of the world where there was no sensing before. So this also is still radar could be considered a sensing type environment. So I was told to keep this to 20 minutes, and hopefully I did.
You're doing great.
Did I? Okay.
Yeah.
Okay, great. So that was some of the products that had to do with severe weather, some of what we're doing in terms of the data behind the scenes on how this is game changing, okay? Because the old way didn't work any longer. We just couldn't keep doing this to get really precise and real time like we are now. Okay. Is that good? Are you going to questions?
Terrific. Go for questions.
If there's any questions, yeah, please.
You kind of forgot one